Well, whilst you were enjoying the break, I was troubled by something, and I came back to investigate it, and determined that the agents within this model were being connected with each other indeed, but they were being connected based on by virtue of their original position, not their position after they jumped to the home. And we really wanted them to have a position as given by their home. Now, there's two ways we can do this, and Dylan and I were discussing actually three ways. And Dylan had a nice suggestion for one way to do it, but I think I have a much more beautiful way, Dylan. So with your leave, I'm going to try something out. It just occurred to me, yeah, I've done it that way before, I believe, and I think it should still work. So let's go try this. What we're going to do, ladies and gentlemen, is we're going to go back and we're going to enable within each person, we're going to enable view of the connections. Okay, view of the connections by clicking on connections within person and check draw line connecting agents. This next section is going to put a premium on having network information, so we want to be sure this works right. So back in person, connections, we're going to go down and check draw line connecting agents. Step one. Step two, we are going to go back, and despite my earlier statements, we're going to go to main and set the distance over which a given pair of people will be connected. If they lie within this distance, they'll be connected. That distance will be 75. We changed it, I think, to 10, something like that. We're going to change it to 75. Where was that? That's in main. Scroll down to this space and network area, and it's the connection range 75 there. Okay, in connection range. Now, left alone, what you would see is most unpleasant. Does anyone remember what we saw when we did that before? We saw something, ladies and gentlemen, like this. Do you remember that? It was the most unpleasant prospect. And what was going on here is that people appear in a certain position. They only get assigned to their position later when they enter that state chart. They only get assigned to their home. So they get connected up before they're assigned to their home. And I think there should be a way around this in a different way. Dylan suggested one way, which would work. There's another way which would have a heavy computational load, but I think there's a third way that perhaps is the most favorable of all. So I'm just going to try this. And I'd ask you to just watch as I try it. I'm going to, so Dylan, watch this. If it head me off, but I think we should be able to say the initial location of the population is in the specified point. And the specified point can be given by self.home.getX and self.home.getY, like that.
I think that should work. And I guess it depends on any logic sort of operation, but
yeah.
It serves that should work.
Indeed. And so I'm just going to run this, and we'll just make sure it works hunky-dory, and then you can put it in place. And the prognosis is unencouraging. Okay, so let's try this. Let me just go make sure I didn't make a mistake at the specified point. Yeah, that should actually work just fine. So that's not clear to me why that would not work. We're assigning them to the location at the home. Well,
what probably that means is creates the population, sets their parameters, does the startup code like applying the network and applying the locations.
Yeah.
Applying the network, and then it probably does the initial.
That doesn't make sense.
Well, anyway, we do have a.
We do have a workaround. Yeah. Okay. Just Could you check that out a little bit more? Because that should work, I think, by all intuitions.
Okay, so I'm gonna like dive into this for a while then. If
Yeah.
anybody needs help, point at any.
Okay.
It's like-
Okay. Well, a beautiful theory crushed by an ugly fact. Thomas Huxley said it first, right? Okay. So ladies and gentlemen, we'll have to go do it the other way, which isn't too bad. So, in main, I'd like you to go to on startup. And so if you go in main, you could scroll down to agent actions, and where it says on startup, you will type the following: this dot apply network. Okay? This dot apply network. Okay. And so that's, again, I went to main, went down to on startup, and I said this dot apply network. And having done that, I can now run the model, and it should see something like this, which is what we want to see. We want people to be connected with others in their immediate vicinity, and unfortunately, the beauty of it is quickly lost. But it's come on, okay, there. People are connected locally with others right around them. That's what we want to see. And indeed, this network is going to be serving as a conduit for transmission of, in this case, pathogen, but it could just as easily be transmission of knowledge, attitudes, beliefs, norms concerning health behaviors. Okay? Are we ready for the next stage? Are we ready for the culmination of the afternoon? Indeed, perhaps of the day. Okay? So, ladies and gentlemen, I would like to ask for your attention as we make the big push here. So we're going to put in place a mechanism that's going to basically capture stages of natural history of a condition. So I'd like to go to person, and I'd like you to scroll over from this care-seeking state chart, and we're going to create a new state chart. So I'd like you to go to Palette, the state chart area, and create a state chart, and this one will be called infection state chart. Okay? Infection state chart. Okay. Next, we are going to have a state called susceptible, another state called exposed. Maybe it should be called in incubation. Incubating. How about that? Incubating. Incubating, meaning that they're infected but not yet infective. There'll be another state which will be infective and symptomatic. Infective and symptomatic. And actually, that's all we'll have as far as states. Now, there will be a link from susceptible to incubating. And this link, ladies and gentlemen, will be a new type of link. This link is called infection, but it could represent being influenced by a imitative behavior in some sort of health behavior, for example. And it is going to be is going to be a message transition, meaning when we're exposed by another person to some message, and the particular message that it will look for is the message exposed. Where did we have exposed? Anyone remember where we put that in earlier? In the option list for messages. The message is exposed here. Okay? Next, there is going to be a transition from incubating to infective and symptomatic, which is going to be based on a timeout associated with incubation period in days. So the timeout here is going to be based on days, and its value is going to be given by incubation period in days. Do you remember we created that parameter before? Where did that live? In Maine. So we need to say not just incubation period in days, which is this implicitly this dot incubation period. We need to say main dot incubation period in days. Okay? This main thing is because any logic automatically provides us with a reference to main here. Main dot incubation period in days. That's the timeout. And this is going to be called, this transition from here to here is going to be called becoming infective. Okay? Great. Next, ladies and gentlemen, next we're going to have a transition from infective and symptomatic back to susceptible, which is going to be, I'll just click like that, which is going to be associated with recovery. It's going to be called recovery. And it is going to be, very importantly, treatment mediated. It will only be conferred on treatment, so it will be based on another message, and this message will be cured, which was also one of the members of that option list. We are cured by the hand of the physician. So you can imagine administration of antibiotics will cure this malady, and we will go back to a susceptible state. Okay? Now, we're most of the way done with this state chart. Most of the way done with the logic. But there's a, there's two key pieces that we still have to have in place. To wit, we need a way when people are infective to spread the infection. Okay? So, ladies and gentlemen, in order to put this into place, we will add what's called a internal transition here, from that state to that state. In this case, it's internal. They won't actually leave the state. This transition will be called contact. It will be occurring at a certain rate per day. And what will the rate be? It'll be given by main dot, anyone want to guess? Contacts per day. That's what that rate is. It's a per day rate of contacts per day. And there was a question earlier, it may have been from Matthew, about if we want to have things in different time units. And this is an example. We have contacts per day, and therefore when we use it, we want it to be per day, as indicated by this per day. We don't want to make this per hour and use contacts per day. That wouldn't make sense. Okay. Okay? Now, this thing is firing off at this contact rate per day, but it needs to do something. It needs to take undertake some change. And where do you think that lives? Where do you think we would put that action? In the action. It's late in the day, I know. It's in the action. In the action, ladies and gentlemen. We need to put the change associated with this in the action. So what change? What change does there need to be? We need to send someone a message. One of our contacts, one of the people in our network, we're going to send them a message saying you've been exposed. So this is how we do this. This, I'm going to send to random connected a message. What will that message be? It'll be the exposed message. Let's follow this through. Let's think about this, ladies and gentlemen. So this person that receives the message, if they're in the infective and symptomatic state, at the incubating state, that message will make no difference. There's no outgoing transition that responds to the message. If they're effective and symptomatic, there's this outgoing transition back to susceptible, but that responds to a different message, to which it responds to the message cured. But it's only if that other person is in this susceptible state, if they receive this exposed message, they will go from susceptible to exposed. So here, we're having this person, think about it, this person is engaged in some sort of behavior. Maybe this is gonorrhea or chlamydia, and there's some sort of sexual contact that occurs once per day. They have a set of people in their sexual network, and they expose one of those people per day to their bug on a per day basis. And if that person nearby them who's interacting with them is incubating or an infective state, it's not going to make a difference. But if they're susceptible, they're going to go to incubating state. Okay? So that's an effective contact rate with a sort of infecting dose. Now, in general, if we have a situation like this, we'll often put a branch in between susceptible and incubating to reflect the fact that it's not a certain thing. If someone gets exposed, maybe there's a 95% chance they are not infected, only a 5% chance they're infected, in which case we'd use a branch, and we'll see if we can incorporate that in a later example. But most of the time they would just go back to susceptible, 5% chance they go on to incubating. Very easy to do. We won't do that in the interest of time. Okay? Okay, ladies and gentlemen, so we just put that mechanism into place. There's only one final component. And this is a component that's, again, of tremendous relevance for chronic diseases, and indeed for many conditions. And that concerns the fact that when we come into the state chart, where do we start? Where does everyone in the population start here? Susceptible. They all enter there. This is the mechanism of entry. And in general, we don't want that. We want a population that's distributed between several states. So, ladies and gentlemen, I would like to drag this up, and we will use a branch right now, a branch transition. And that transition will divide people up between these states. Now, I'm tempted for aesthetic reasons to draw it differently, but I'm going to put a branch here. And when we put a branch, we're going to have choices as to where that branch, whither that branch leads. Okay? So we're going to drag in transitions from that branch. The default transition, as indicated by a dotted line, indicates they're going to susceptible. But we're going to have similar transitions between that branch and incubating and infective and symptomatic. Now, it takes a little bit of doing to draw this nicely. But if you drag in one of these transitions, one way to do it is to double click so you can get it to bend a bit and drag it down like this and drag it up to here. And maybe I'll drag it like that. Okay? Now, you notice this one too is colored. And that indicates it thinks it's the default. But we'll actually only do this under a certain condition. And in fact, as I recall, there was actually just a single variable we had. So this should actually go, I stand corrected, this should actually go to infective and symptomatic, because a certain fraction of the population is to start infective and symptomatic, okay? So ladies and gentlemen, I would like you to go here and I would like you to set this here, so be on a condition, and the condition will be, I'm thinking, should I do it one way or should I do it the other? Fine, we'll do it this way for now. The condition here will be random true main dot fraction initially infective. So let me put that up here. So anyone remember what random true does? We saw it yesterday. It flips a coin that it is true with a certain probability. The probability here is fraction initially infective. So it flips, ladies and gentlemen, a coin with this probability. So suppose 5% are initially infective. It's flipping a coin that with 5% chance ends up heads up. In other words, true. And if it ends up true, ladies and gentlemen, it will go this way rather than this way. But by default, it will go this way. So this initial branch basically divides people into two categories here, down to here, or to infective and symptomatic. And in general, we can generalize this mechanism to divide people up into any category. And we may see that in coming lectures. If not, I'll try to give you a video which shows that. It's very readily done. It's best done with an options list and time as a fleeting. So here we're dividing up the initial population which is susceptible with just a small fraction that are infective, and we're going to see the consequence. Okay. Next, we're going to take our lesson from yesterday, ladies and gentlemen, and we are going to have people's color change based on their health status. And how did we accomplish that yesterday? Does anyone remember? How did we have their color changed based on their health status? What did we have in the model? We had a variable, right? Remember that? And what was that variable called? It was called color, indeed. So, ladies and gentlemen, I would like you to go and put in place a variable called color as well. And I would like you to make its type what? Does anyone remember what this variable was yesterday? What sort of type of variable was it? From what set? It's going to be called color. From what set of values were its values drawn? Were its possible values? It was from color. In order to say type, we need to say other, and the type was color, with a capital C-O-L-O-R. Its initial value will be black. And then, suppose for susceptible we want it to be green, incubating we want it to be yellow, and infective and symptomatic we want it to be red. How do we do this? What do we have to do? In the entry action, we have to type what? Color equals what? Green. And then color equals yellow. Oops. Color equals yellow. And then color equals red. You comfortable with that? Okay. Okay. And let's set the color of this visual state to reflect that. So we'll make this one red. We'll make this one yellow, leave it yellow, make this one green. There we go. Okay? What do you think we'll see if we start the model now? Oh, well, are we done with color? Are we done with that logical chunk of work? Have we finished that task? Or does one key step remain? Indeed. Okay, I think one key step remains. What is that key step?
How does the message keyword get to?
Okay, the message cured, yeah, we're gonna come to that. That's a good point, and that's a very good
Key
point,
step.
Chris. Where that is gonna be a key step, and that's coming up. But even before that, that's a key step. Is color complete? If we change color to be pink, will we see pink? No, what do we need to do?
Apply it to the little.
Yeah, we need to apply it to the little man. That's well said. So this little person needs to have their color set. Now, this little person is more complex than you think, and you can click on it, and it turns out that you can, if you click on it well enough, you can get it to show you fill color, and you'll be all set. But it's a little bit difficult to do. So I'll show you another way you can deal with these things. It's much more reliable. You go over to Project, you go to Person, you open the presentation, you open Person again, and there's something called Shape Body. Now that's the ticket. You click on Shape Body. We're going to set the fill color here to be color, the variable, color. Okay, color. Ladies and gentlemen, we set the fill color to be color. How did I do that? I opened up Person in the projects. I opened up Presentation. I opened up Person again. There was something called Shape Body. I selected Shape Body. I went to Fill Color. I clicked next to it, and I put in color. Okay? Color. Are we okay with that? Okay. So that's good. Do you want to run it? Okay, let's build early, build often. TAs, prepare for deploy. Annie, Dylan is in investigatory mode, and he stands ready. Okay. Okay. So those of you who feel ready, you can go ahead and run this thing. What should we see? What should we see? Ooh.
Look, they're infecting each other.
Okay. Oh, look, there's some infection going on in a somewhat entropic fashion. Okay, ladies and gentlemen, let's temporarily stop them exhibiting care-seeking behavior. We'll get to that in just a moment. But let's disable care-seeking behavior, although it would appear to be associated with infection spread behavior by appearances. Okay, ladies and gentlemen, let's stop them going in for care for the moment. Let us watch this, okay? I would like you to take this transition and let us set it to be a rate transition with rate what? How would we stop this? This is a very good lesson in trying to figure out how models work, to try to understand what's going on and to simplify. We'll sometimes want to disable transitions. And how?
Rate 0.
Rate 0. To stop that transition from occurring. Okay? Another way would be make it depend on some message that isn't sent. But rate 0 is the simplest way. Rate 0. Okay, yeah?
Could we not have just said ignore?
Okay, so ignore, so that thought flashed through my mind. The problem is I think any logic will throw a fit because it can't see any way to get to this state then, and so it may be quite unhappy. Okay, maybe it's happy.
But what if you did it to the whole thing?
Okay, yeah, it's an unhappy camper. Element is not reachable. Yeah, I could have done it to the whole thing. It's true, to the whole thing. That would have been possible. but I can also just disable rates. And in general, that's a good skill. So we set it to rate, and actually, when we set it back to timeout, it would remember its old value. So I'm going to say rate, or you could set it to be based on a condition of false. That would be another way to do it. Okay, here we go. Okay, now we have this individual, and look, what's going on around them? What's happening? What's happening, ladies and gentlemen?
The infection is spreading.
Okay, there the infection is spreading. Because as of yet, as Chris noted, as of yet, there is no cure. There's no cure being dispensed yet, right? Okay, ladies and gentlemen, the clinic sits here unused, and individuals are spreading the infection betweenst themselves. Okay, let's just pause for a moment and think about how this infection spread is happening. So I just want to make sure we're solid in understanding what's going on. This process is a contagion process. Contagion processes here are being used to look at contagion of pathogen, but the same basic idea could be used for peer educators for ideas about safe sex campaigns. It could be used to think about spread of norms or risk perception in the context of a epidemic or of an outbreak. It could be used to represent spread of physical activity norms in certain contexts. So I want to be clear about how this is occurring, the spread. So what's happening is, ladies and gentlemen, if I recount this now, we are starting with a certain fraction of the population initially susceptible, another fraction infective or symptomatic. How is that occurring? Well, up there in Maine, we had a parameter which was called fraction initially infective. And that fraction of the population is starting in this infective and symptomatic state. Okay? They're starting in that infective and symptomatic state. And ladies and gentlemen, some people therefore start in this state, some people susceptible. Whilst in this state, whilst in this state, these people at a certain contact rate per day, given by contacts per day in Maine, send a message to a random one of their connections, about once a day for the current parameter. What that means is over their network, their connections in the network, they'll be sending a message. And if one of these contacts is susceptible and they receive that message, what will happen to them? They will get into incubation stage and then infective. And they'll start to spread. Now, right now, are people recovering from infectivity? Indeed not. They're staying in that state, and hence the red character. The red character of it. It's not just the east that is red here. It's the whole canvas after a while. Okay? So, ladies and gentlemen, let's move beyond this and let us now put in place the mechanisms to complete this example and to render this population a cure. Okay? Okay. Now, okay, ladies and gentlemen, we have a neglected area of this model, an area of this model that as of yet remains virtually empty. Embryonic is to be generous. And that area is the clinic. And I would like to add in a clinic. Okay? Okay, so we've gone through this morning. We can do it now. I know it's asking a lot of you. It's after 4. But I'd ask you to win one for the Gipper. Okay? Okay, so if you could double click on clinic and go to palette, I'd like you to go to the process modeling library and I'd like you to do something different than what we did this morning. Does anyone remember this morning when we had people flowing in? What did we add? A source. And that's great, and there's ways to deal with it through that, but it's much more convenient if we use this thing called enter. Enter. So we'll drag in an enter, and this will be called WalkIn. WalkIn. Okay? Good. Okay, now, ladies and gentlemen, I would like you to now put in place a queue. Okay, we're going to put in place a queue here, and we'll have this queue. We did a very similar thing this morning. We've seen this before. In the interest of time, I won't modify it. And then we're going to put in place a seize. Now, it turns out those two things can be combined in what's called a service block, which is one of Jeff's more prized components. But I'm going to separate them as we did this morning. And now, and in fact, it's combined with a delay, moreover. I'm going to put in a delay, which is going to be given by treatment. And indeed, following that, we're going to release the healthcare worker. And following that, ladies and gentlemen, we are going to have an exit. Okay? Now, we are going to further have a phenomenon that's a left without being seen phenomenon, a phenomenon of leaving early. And Jeff, you told me the name to use for that, but
Did not wait.
did not wait. Okay, so if you double click on this here, remember we did this morning? Remember that? We click over here, click here, and click down here. Oops, that didn't connect. Do you see how that's not connected? It's white. Do you see that? This is white. I can zoom in. Do you see how this is white? That's a sign it's not connected. I need to connect it. It should be green, just like this. There we go. Ladies and gentlemen, this will be the connector associated with did not wait. Okay? Now, in order to seize and in order to release, what do we need? We need a resource and a resource pool. So for the project, we're going to add a healthcare worker, okay? I could do this. We're not going to really need. I'll do it without actually creating an agent explicitly. So what I will do, and I think this should work fine in AnyLogic 7. I'm going to go down to resource pool, drag in a resource pool called healthcare workers. Oops, not healthcare works, but healthcare workers. Okay? Healthcare workers. And the capacity of the healthcare workers will be initially 1. Single person. And for the queue, I would like you to set it to be maximum capacity. And I would like you to enable exit on timeout. And the timeout transition to represent what Jeff called the impatient patients will be associated with a delay of, thought I had these in here, but that's fine. Be associated with a delay of from a triangular distribution, drawn from a triangular distribution with a minimum of 30 minutes, a maximum of let's call this in hours. Let's call it in hours so it's more convenient. We'll specify in hours. Triangular distribution will be from 0.5 to 4 hours with a mode of 2 hours. So 2, 4. Now, any logic is very, it normally wants the max second, but it's very loose about it. So I'm going to put it this way, but you could actually order them in any order, and it will be fine. It's a very special case where they took pains to make sure that's the case. So here, this is for balking. This is for did not waits. It's a minimum of 30 minutes, a max of 4 hours, and a mode of 2 hours. Okay? How long they're willing to wait for treatment. Okay? So think about an STI clinic. That's for the timeout. I enabled the exit at timeout, and I put that in there. Okay. Next, any questions on that? We did it this morning, so it should be fairly familiar. Next, we're going to go to C's. Ladies and gentlemen, for C's, what will the resource set be? Anyone want to say?
Healthcare workers.
Indeed, healthcare workers. Next, and that's all. Next, treatment. The capacity here will be maximum capacity, as many as we could support with healthcare workers. The treatment conferred will be associated with the delay time, ladies and gentlemen, of that's as given here, the draw from the triangular distribution in hours. Triangular 0.5, 1, and 1.5. You notice that any logic, even in the default, Jeff, uses this alternative rendition, which I think is inviting confusion, but it's fine. Okay, so that's treatment. We're just used what they put there already, and it's in hours. Anyone want me to spend more time on that? Are you ready for the next one? Ready for the next? Who would like a little bit more time? Who would like TA help? Okay, wow, you folks are doing well. Okay, release. We're going to release, there's only one type of resource. We released all seized resources. And finally, exit. Okay, now, does anyone notice that I omitted a key thing that we had last time?
You can put the agents in the resource pool.
Excuse me?
You can put the agents like nurses or whatever in the.
Okay, exactly. Yes, that's right. We just said use its own resource unit of agent, and that should be actually fine. It'll be fine. We didn't distinguish them. We could add a healthcare worker, but I don't think in the earlier version of AnyLogic you didn't have to, and I think this time it will also be fine. But we'll give it a try. But there's something else I didn't do. Do you remember for source? What did I specify for source? Anyone remember? Was source? Yeah, rate. But here, that rate, we're not going to specify it directly. Why not? From whence will it come? Or whence will it come? It will come when people are in the underlying population when they get infected and are symptomatic. That's going to be driving it. We're no longer going to be specifying some exogenous rate, 10 per hour. Instead, what's going to be driving this is people's health state in the population. This is extremely important because it means that we're bringing together these components. But we haven't finished yet. The health state of the population is going to drive presentation. And the quality of care offered here is going to drive the health state of the population. Okay? So, ladies and gentlemen, I would like to go over, and we are going to have treatment affect people's health state. Now, right now, we've just shown it like this. I'd like to ask your pardon, and I'm going to modify this slightly. And specifically, what I'm going to do is I'm going to drag in here, select output. Okay? And this select output is going to be called is treatment successful? Okay? If treatment is successful, they're going to go directly to release. And if treatment is not successful, they're also going to go to release. So you may wonder, why am I having two paths here? Why two paths? Well, if we look at is treatment successful, we can have different elements here. If we leave and it's successful, one thing will happen, otherwise something else will happen. Let me ask you to tell me this. If we want to change someone's health state, what will we do if the treatment was successful? If the treatment is successful, they will be cured. Indeed, they'll be cured. They'll be cured of their malady. So, ladies and gentlemen, under exit true, what we're going to do is we're going to send them a message saying you are cured. Okay, now we have to be a bit careful because I've been sloppy about something and I stand corrected. Ladies and gentlemen, what we should have done, and I apologize sincerely for this, from walk-in all the way down, we should have made sure that the agent type is person. So we're going to go down walk-in, Q, agent type is down here in person. Oh, and look, it's already adjusting it for us, C's. Person, good. Okay, treatment, person. Now for treatment, please make sure it's maximum capacity. Just double check that. Make sure it's maximum capacity. Next, is treatment successful? Person. We'll come back to that one. Release. Person. Good. Exit. Person. Excellent. Okay. Okay, now back to is treatment successful. What are we going to have to do? We're going to have to tell them they're cured. How do we tell them they're cured? By sending them a message. So, look here. It says use self, semicolon, agent. Now once again, it is not quite the mystery of centuries, but it's confusing. Self refers to the block. Agent refers to the agent being processed through, the person. So we're going to say this dot send. We're going to send the agent a message. The message will be cured. Cured. And to whom will we send it? To the agent. That is what we're going to do. When they exit this transition, if it were successful, with that probability that we're going to assign, they send the agent a message saying that you're cured.
Why is it agent and not person?
It's a good question. Here, it's called, it says that two things are available. One is self, the other is agent. The agent names the entity that's flowing through here. So through this pathway here, this care pathway, there's somebody flowing through. And the way to refer to that person that's flowing through is agent here. That's just the deck of cards it's handed us. That's how we have to refer to the person that's being treated. Person flowing through. is agent. Self would refer to this block, I think. Okay? Agent. Okay? Are we okay with that? So here we are curing the agent. So the healthcare process, presentation for care, will often lead to cure rates. Now, the probability of this I will now set, and I would ask you to go add a parameter, and it's going to be called probability of cure. Its default value would be 0.95, and we will use that for the probability of cure. Oops, probability of cure. There we go. What did I do? I added a parameter called probability of cure. Really, it's probability of successful treatment. And then for this, we use that probability to reflect the likelihood that they would be cured. Okay? Good. And then after that, they're released. You'll notice if they leave through the other pathway, nothing happens. What does that mean? Suppose someone's infected, they present for care, they come down this pathway, and it flips the coin, and they're in that unlucky 5% in this case who are not cured. What happens? They stay in that state. They just stay in that state. Are we okay with that? Now, ladies and gentlemen, sending them a cured message, what does that do to them? Let's go back and look at the state chart. What does that do to them?
Return to susceptible.
Yeah, they return to susceptible. Okay? Great. Okay. Ladies and gentlemen, we're almost done.
Could you just click on the probability of cure?
Sure. You bet. You bet. So I'll go back to clinic, and probability of cure, I just left it as double, and it's 0.95 by default. Okay? 95% chance treatment is successful, which is, there are treatment failures associated with administration of antibiotics, most certainly. If you have to take a systemic antibiotic, and you're doing so, for an STI or some other complaint, there's definitely a chance that there'll be a treatment failure. Okay, ladies and gentlemen, so we have the model and the evolution of health status of the model driving people's presentation, or excuse me, driving their infection status. And we have, when someone goes through that process, that clinic process, they can be cured here. But we still need to hitch it up so that they actually present for care in the clinic, right? So, ladies and gentlemen, let us turn our attention to, once again, to this state chart. We disabled the state chart, remember that? We set this to be a rate of 0. Now, ladies and gentlemen, we will no longer do so. We will set this, we'll use a different approach. Okay? So, ladies and gentlemen, oh yes, yes, I'm sorry, there's one other thing we want to do in the clinic. Sorry, one other thing, and that's associated with the exit action. This exit action, ladies and gentlemen, needs to do something. It needs to send the person. How do we refer to the person? Anyone remember? Agent. We need to send them a departed from healthcare facility message. Okay? Back to the agent. We're sending it to the agent saying, you've left the healthcare facility. Now, you're done with that process. Where am I? I am here at exit. At exit, we send a message to the person. The clinic sends a message to the person. That's what this is, the clinic. I'm in the clinic. I send a message to the person who's flowing through saying you've departed the healthcare facility. Okay? So, are we done with that? Are people okay? Or here, I'll put it up on the big screen. There we go. Ladies and gentlemen, we're getting close to being done. We're getting close, ladies and gentlemen, to capturing the reciprocal causality between population health and service delivery. The fact that if our service delivery systems are broken, if they don't confer timely care, if they don't confer high quality care, it'll affect the health of the population. And if the health of the population is adverse, it will affect the loads, the service loads in our service facilities. No small matter. When we think about chronic diseases, we think about encouraging self-care. A lot goes on in the home with the patient, to be sure. A lot goes on of necessity and prevention. That's really where the action's at, much of it. But in the prevention side, there's service delivery components, implementation science side, rollout of programs, making sure that individuals are well supported in programs that aim to enhance cooking skills or aim to enhance physical activity. There's often service processes involved. And capturing the reciprocal causality between them can be quite valuable. And once it comes to people who are burdened by actual illnesses, by comorbid conditions and others, representing service presentation can be important. Hence the naming of this course on chronic disease across the care continuum. Okay, so let's go back and let's go to person and let's just finish this off. We only have a few components still to go. So, number one, this return here from undercare to non-undercare, it's been a timeout. Under what conditions, just think about it. We've done this, the relevant piece, in the last 5 minutes. Under what conditions do you think they'll go from undercare to non-undercare?
They get that message.
They get the message, departed healthcare facility. So we will change it to be message, and the message is a particular message, departed healthcare facility. Let me do that again. I changed this to be triggered not by a timeout, but by a message. And then it will be on a particular message, to wit, departed healthcare facility. Okay? Are we okay with that? That's great. So when they leave the healthcare facility, they'll go back. And whence will they go? Or whither will they go? To home. Now, Dylan has noted that in version 7.2, he researched it, and you can actually just say move to home here. So I trouble you unnecessarily, those who have 7.2. My version is 7.1.2, and I don't have that luxury. But it's been a long time coming, and it is an improvement. Okay, so, ladies and gentlemen, the part that's missing, the key part that's missing is what? The key part that's missing is this part here, driving them to care. And there are several ways we can capture that. I would like you to capture it as following, okay? Okay, so, ladies and gentlemen, I would like to go to the following, okay? Here we go. So, I would like to set this transition from not seeking care to in transit to care. We're going to divide this up into pieces, and Jeff will notice this was a little bit different from the strategy I've employed in previous ones, and I seek his feedback. So we're going to drag this down, and we're going to turn this into a branch transition. This is partly because I want to teach you a little bit more about branch transitions. Okay, ladies and gentlemen, with this branch transition, we're going to go down and find it, state charts, branch transition, here. You'll notice elements of state charts are also available in the agent palette, but I'm going to do this here. So, ladies and gentlemen, they will only go in transit to care under a certain condition. What will that condition be? The condition will be that they are currently actively symptomatic. Okay? So the condition here by which they will go on to transit to care will be this dot. Do you remember how we asked, is an agent in a state? We said this dot, what is it? In state. Man, you folks are good. That's great. In state. And what state will we ask if they're in? In what state will they seek to know if they're in? Gosh, that sounds horrible. In what state do we wish to seek to know their status? Infective, excellent, and symptomatic. We want to know if they're infective and symptomatic, they'll continue on. Otherwise, they will go back to this under care here. Otherwise, they will go back to there. And we can prettify it if you're inclined towards that. First of all, we'll make this the default, okay? And I'm trying to click here so we can draw it a little bit more nicely, like that. Oh gosh, no, it was kind of nicer, like that. Okay, something like that. It'd be kind of nicer even if this could be dragged over like that. Okay, so ladies and gentlemen, here with a certain rate, and this rate will be 0.05 per day, they will go. So basically, when they are sick per day, when they are sick, ladies and gentlemen, on about 1 over 0.05, about once every 20 days, they will go in for care when they're sick. What's going to happen is once every 20 days, it'll check, are they sick and symptomatic? If not, they'll just stay here. Otherwise, they will transition onto care at that point. So it takes them about 20 days once they're ill to transition onto care. 20 days, okay, on average. Kind of similar to what you might expect for men with gonorrhea, actually. So here we have this transition. Once every 20 days it's taken. If they're not symptomatic, then it's only if they're symptomatic that they will continue on. Let's put it that way. Infective and symptomatic, otherwise they will stay here. Okay, who would like me to show a piece of this? Yes?
The transition from the branch to the entry.
This one here?
Yeah.
Yeah. So I asked, it'll take place under a certain transition, a certain condition, and what will the condition be? I'll put it up on the big screen. Basically, it's asking, am I in the infective and symptomatic state? Now, ladies and gentlemen, you may have noted that when I did this in Maine in statistics, I actually had to say person.infective.symptomatic. And as a general rule, you can always do that. So I would encourage you to do that just to avoid confusion. Here, you actually don't have to do it because we're inside a person, but as a general hygiene, it's kind of a nice thing to do. And if you use it, it will prevent you from getting into trouble. So I'm going to do that. I'm going to ask, am I in a certain state? What state? It needs to know, to do its job in state, needs to know what state am I asking about. Its job is to say, you give me a state name and I'll tell you if you're in it, if this person is in it. So I say, well, the state I want to know about is whether is this one inside person, infective and symptomatic. And it will return for me true or false. If I'm in that state, it will return true. Otherwise, it will return false. And if it returns true, ladies and gentlemen, if it returns true, only under that condition will I continue on. Otherwise, by default, I just go back. I don't have to put a condition. This is just the default. If I don't go on, I'll go back. Does that make sense? Who has a question? Who would like me to show something? I would just note this transition, or this thing is the only other thing I modified. I modified this rate to be 0.05 per day. It was previously given by, I think, a rate of 0.
So that, not under care, that everyone in the population is not under care, and that
So-
0.05 per day, so I'm not quite sure, you said that if they were sick, I'm not quite sure how that.
Right. So this is a good question. So Chris, every 20 days on average, that's
Yeah.
1 over 0.05 because it's a hazard rate. Your average time in this state before you go down there is about 1 over that hazard, is
Yeah.
1 over that hazard. Every 20 days you examine, are you sick or not?
Oh, I see.
And where does that are you sick or not examination occurs? It's right here. And if I am feeling sick, I'll go on to seek
Yeah.
care. Otherwise, I'll just stay in this state. I'll just return to this state.
Do you need to move the code for the action from where it is currently to?
Thank you. Thank you, thank you, thank you. You just debugged my code, and I'm grateful for it, Matthew. So, Matthew just noted, this code here, getting the clinic is not a problem, which is the nearest clinic, but then starting to move to it, that would be a real problem. If I started moving to it, and I'm not in transit to care, really this code should be put here, or put on the entry action to this. And I'm going to actually put on the entry action to that. So what did I just do? I just moved the code from here, and I moved it to in transit to care. Thank you so much. That's much appreciated. Excellent. Much appreciated. Man. You wouldn't want to be a TA on some of these questions. Sorry. Yeah, no, that's great. Good. Yes, Dylan. Yes, Jeff. Sorry.
I guess one logical problem is you've kind of got
I know.
you've got a non-exit exit. Yeah.
A non-exit.
Well, you've got I mean, you're going out to think about whether
You're going out to think about whether exactly.
You're going outside to think. Yeah.
Exactly, but it's a little bit better than a self-transition every 20-day checking. Am I in that? Yeah, I think it's arguable if it's cleaner than the alternative we've used before.
Well, it's cleaner, but yeah.
Yeah.
It's,
Yeah.
Its own other set of problems.
It has its own set of problems, almost a logical reversal.
Yeah.
Every 20 minutes, every 20 days, you check if you're sick, and if so, then you go. But anyway, okay. So, ladies and gentlemen, are we ready to run this thing? Okay. So let's go run this. So, what do you think you should see after these changes? Okay. No one's going yet. Are there people who are sick? Indeed. After how long on average should they be seeking care?
20 days.
About 20 days roughly on average. Okay, no, they're not. Okay. Okay, come on, guys. Okay, so what is going on? Are we not there? Oh, sorry. Did they? I saw some movement. Okay. Okay. So let's see what's happening. Are people moving for care or not? There is some movement. Okay. Let's go down to the clinic. Okay. Has anyone? Oh, wait a minute, folks. We forgot the key thing. We forgot the key thing. Sorry, it's late in the afternoon. Well, nay, I don't know what time it is. It's for me. Okay, yeah, we forgot the key thing. Sorry. In my enthusiasm, we forgot the key thing. Right now, they're moving to the clinic, but they're not actually entering the clinic right now. They're not actually entering the clinic process. So what we need to do is we need to do one more thing. We need to say nearest clinic dot dot walk-in dot take this, take me. In other words, go take me into the clinic. What is this walk-in? Do you remember where that occurred? Yeah, it's that entry in the clinic. We're saying, hey, go into this place in the clinic. Take me in. Enter. Sure, you bet. So let me put all of this here that's occurring there. So there we go. I'm saying for the nearest clinic and its walk-in, take me in. Me being the person who's sick. Take me into your clinic. Right there. Okay? Okay. Okay, now. That's good. That's good. Okay. So I didn't change anything in the first 2 lines. All I did was add this line. Okay? Okay? Are you folks feeling okay? Okay. Okay? Okay. Can we try something now? Now, I'm still not convinced. I still think we might have goofed on something. But at least now it'll be more clear if we're actually going to the clinic. We could check, are people coming into the clinic? Okay, so here we go. And we're marching along, and we're going to see if people are coming into the clinic. Okay? Okay, okay, now someone has changed color there, okay. Yeah. Okay, let's just go check. Okay, the clinic doesn't have anyone in it. Okay. Okay, there is something. Oh, okay, now we're starting to see some movement. Okay. Okay. Oh, look at that, man. Okay. Okay, there's a lot going on there visually. There's a lot of connections taking place. Let's go turn off those connections. Okay, let's not have them be visible. So where do we go to turn off the connections being visible? Anyone remember? Person connections, and we want to uncheck draw line connecting agents. That will clean things up quite a bit. The connections will still be there, just we won't see them now. We'll now run it, and we should see something that's a little bit cleaner. Maybe this will help see some movement. I'm actually not entirely sure if there is some bits of movement going on. If we look at the clinic here, we still have no one coming in quite yet to the clinic, which is puzzling. I would have expected people to be coming in, okay? And now we're starting to see some movement to the clinic. But it's apparently occurring at a sufficiently, okay, yeah, you can actually see people moving in. I'll slow it down a bit, but let's increase the speed a little bit, and now I'm going to decrease it. And you can see people coming to the clinic. Do you see that? They're coming in, and then they're going back from the clinic after some time. So people are coming back. Some of them are coming in, they're getting cured, and they're going back. Okay, there we go. And if we go to the clinic, we will see that the clinic is having people process through it. How many people have gotten cured? 18. There have been 5 treatment failures right now. And the clinic is still at a low utilization. But we see people coming into it, transitioning into it, and returning back home. So I'll slow this down a little bit. You can see here they go. And then after some period of time they will emerge. Remember the time unit, the time unit is in, what is the time unit in? Anyone remember? It's in hours. So I was thinking that after 20 days they should be presenting for care. Look at this. Look, he's going in. Okay, now it's almost like he got cured along the way. Okay, something's going in. Something's going on, okay. Okay, now this one is returned upside down in a cured state, okay. Okay, okay, here's another one coming along in a stately pace, okay. Okay, and now he's returned in full form, a whole man again, okay. Okay, they're coming in, they're going through the care process. There was a what? Treatment failure. A treatment failure returning to their community. Okay, and now this one is emerged cured. Okay, so ladies and gentlemen, much of my confusion in saying why weren't they presenting for care earlier is I was interpreting this in days. This is in fact hours. And now, using the mechanisms we put in the morning, you could imagine having this clinic closed during off hours, right? How do we do that? We have a couple minutes left. How do we do that? How to make the clinic close during, it's only open 9 to 5. What would we do? Ladies and gentlemen? Let's add a schedule. So where did the schedule live? Does anyone remember? It lived under agent, in fact. Agent, let's add in a schedule here. And this will be called, we could just call it, opening hours, right? And we will set it to be what sort of schedule? An on-off schedule, and this schedule will be on a daily basis, okay, repeating every one day, and we will do it at certain moments. So starting at, ladies and gentlemen, and I know there's a Mac issue with this, starting at 12 a.m., it'll be off, it'll be closed. Starting at 8 a.m., it'll be on. Starting at 5 p.m., 5 p.m., it will now be off, and it will remain off then till midnight, okay? That's opening hours of the schedule. I did plus 12 a.m. off. So how did I do this? It's type on off. It defined it in moments. I did days, weeks, and I set 12 a.m. off, 8 a.m. on, 5 p.m. off.
What if you wanted to do Monday to Friday, that close to weekends?
So I think if we had switched it to this, we could have done it. So so here we have Sunday, Monday, Tuesday, and I think you could then define, and I haven't done a lot with this, Dylan, if you, but I think you can define basically an articulated schedule associated with Saturday, Sunday. This indicates it's closed. It's closed, for example. On those days, it's open on these days, and time value here. But I'm going to switch it back to, we just lost it. Maybe I'll do what you suggested. That's kind of nice. Okay, you folks can keep it as you want. But here it'll be off, and then I'll add another one. starting at 8 a.m. It will be on, and then starting at 5 p.m. It will be off, and that's what the schedule will be. Is that helpful?
Right.
Okay, so ladies and gentlemen, this is the opening hours schedule, and the healthcare workers here will be defined now, not directly, but by on-off schedule as chosen from opening hours. Okay?
And just,
Yeah.
that's obviously for the class of clinics. What if you wanted different clinics have different opening hours? You'd have to set them up as different agents?
That's a really good question. The question would be, could you assign dynamically, that's when the model's running, could you assign different schedules to different clinics?
Yeah,
I'm
even-
guessing that
even
you can.
subcountries.
I'm guessing that you can, but that would be something for Dylan, Annie, or I to check out. Okay? But I'd be a little bit surprised if you can't, based on what I know about the mechanisms involved.
With the schedule, why did you start at 12 with off? Why not start at 8 with on and then 5 off?
Well, because it's a great question. To be honest, I haven't played around with schedules a bit, and I wasn't sure if I didn't specify anything with that time unit, what the default would be for that. Like, does it default to on from the start or default to off? So I thought, to be safe, I'll just specify it as starting at off. Okay, just to make sure that I know what the value is there for it. So we could now run this, and we could see the effects associated with this. But more than that, ladies and gentlemen, so now we have a schedule, and you'll notice that there's a time here that's given. It's actually keeping track of the days of the week, and it's keeping track if this clinic is open or not, etc. And now we have people going to the clinic, presenting for care. But if the clinic's not open, they will simply queue up. You notice during this time that we have people queuing up here, and they're awaiting care. And now during the opening hours, those people will be cared for. Yes, Dylan.
Yeah, so with schedules, it looks like they have a pretty good API for really fine-grained things, when it's open, when it's closed. And you could do that on what looks to be like on a per clinic basis, even if you use the same agent.
Right.
So
Oh.
that's just a summary look. I hadn't tried it myself. It's looking like that's the case.
Okay, now you'll notice that we have this population which has rather adverse health prospects. They're presenting for care, but they're going right back to their networks from whence they were infected. Right? They're just being dumped back into their networks. Let's suppose if we were to add a clinic, or maybe add another clinic, another one yet. We're going to add a bunch more clinics. And now the health prospects of the population are still not rosy, but there's a little bit more in the way of individuals who are not carrying that health burden. We could add many in there, but even so, the infection is spreading very quickly. The burden has not been materially alleviated without further behavioral counseling, for example. If it's just, on the dental side, drill and fill, if here they just administer the antibiotics and throw them back without counseling, they may get infected very readily again. They're going back to a susceptible state. And this would be a chance where we could add behavioral counseling. Now, we don't have time to do that here, but I would ask you, suppose we were to do that, rather than peppering the population with nearby clinics, which are going to make marginal difference after a while, because they're going to get cured. After a certain number of clinics, they're going to get cured very, very quickly. The rate limiting thing is not going to be their time going to clinic and waiting for the clinic availability. The rate limiting factor is going to be how long a time they spend in the clinic. And really what's driving this is infection, is very rapid transmittal of infection. So here we have people going back and forth between susceptible to infective. I mean, look at this poor guy. He's going back and forth between susceptible, infective, and exposed in a very rapid succession. So the infection is spreading very rapidly. Suppose we want to add behavioral counseling. How could we do that? Think about it. How would we add behavioral counseling? Well, if I had an hour, we'd do it. If I had half an hour, we'd do it. So what we could do, ladies and gentlemen, is examine the case as an intervention, as an alternative experiment. We could examine a case where we have a choice of two types of options. So following treatment for the normal case, the kind of traditional treatment case, we just follow exactly this pathway. So actually it'll be after this treatment is conferred. We just follow the pathway to release them. For the alternative case, we would, for this case of behavioral counseling, if we wanted to examine that as an intervention, in that case what we would do is we would spend extra time with them. And that time would mean keeping some people waiting, but following that time we'd have a chance of lowering their contact rate, say. So they'd have a lower contact rate. Their risk behavior would be reduced. And as a result, even though we've kept people waiting, and yes, those people are infective while waiting in principle, they could be circulating in the population, infecting people during that time. But if we can influence people's contact rates on an ongoing basis, we may really materially lessen the chance that they'll get infected again, right? So what we would do is we would put in place here a mechanism to sort of say, okay, flip a coin, is their contact rate lowered by a factor of 20% or by a factor of 50%? And we could examine then, by running this model, what the impacts would be across the population in terms of burden of illness, in terms of infection that we see here. How would that affect things? Now, I would note we could also add clinics early on here and see to what degree that heads the infection off in a lower trajectory. My guess is that adding clinics early on, it's not going to make a really big difference here as long as we're subscribing to this very biomedical approach of just treat people, throw them back into their networks. What we really need is behavioral counseling or prevention, and that would be something we could put into here in a service-mediated way or having a campaign to try to cause people's risk behavior to change in a preventive fashion. So if there's interest in this, we could return to that either tomorrow or the next day and put some additional features on the prevention side and on the side of behavioral modification associated with treatment as part of the service delivery. Takes time, but may more than pay off by shifting the behavior of the catchment population in a healthy way. So anyway, that's it for a little hybrid model, and we've seen how it links up on the one hand population health, and on the other hand service delivery, reflecting the fact that both are joint, that innovations in one or investments in one ripple through to investments in the other. Tomorrow, we'll be spending much of our time with GIS and the impact of neighborhoods and the spatial environment, particularly the food environment and the physical activity environment in shaping people's behavior. Okay? So thank you very much, and we'll see you tomorrow. Thanks.